Alright, this lesson is about miscellaneous relationships between angles and arcs and radii and tangents. It's a mixed bag, okay? First things first, however, when it comes to these first 6 problems or so, 7, the thing you need to keep in mind is the relationship between a tangent and a radius. If you have a tangent to a circle, the radius will always be perpendicular to the tangent at the point of tangency. Okay, so if BA is a tangent, it will be perpendicular to radius CB. Alright, and that's true all the way across, right? If AB is a tangent, it'll be perpendicular to BC in all of these pictures. So, let's see, what are they asking us? Man, in the diagram, BC is a radius. Okay, that's pretty obvious. Determine whether AB is tangent or not. So, bottom line, we will be checking to see if somehow these are perpendicular. If they're perpendicular, then yes, it'll be a tangent. If they're not perpendicular, then no, it won't be a tangent. For number 1, we will immediately say yes, it is a tangent, because we're given that it's perpendicular. We're given that it's 90 degrees right away. Yes, and we'll just say BC is perpendicular to AB. Yeah, that's all we need to know. What about number 2? I don't see a 90-degree box or anything, so how in the world am I to know if this is perpendicular or not? I don't have the slope or anything. Well, we can use the fact that the Pythagorean theorem only works on right triangles. So what we could do, were we so inclined, is we could check out the Pythagorean theorem. Does 4 squared plus 3 squared equal 5 squared? So the question is, does 3 squared plus 4 squared equals 5 squared? Well, does 9 plus 16 equal 25? Yes. Yes, it does. Since the Pythagorean theorem holds, then that means this must be a right triangle. So we will say yes. Since 3 squared plus 4 squared equals 5 squared, triangle ABC is a right triangle. So AB is perpendicular to BC. Okay, there you go for number 2. What about number 3? Let's ask ourselves, does 3 squared plus 6 squared equal 7 squared? In other words, does 9 plus 36 equal 49? And the answer to that is no. Alright, 9 plus 36, that's 45. 45 does not equal 49. So we will say no. Alright, AB is not a tangent. Since, here's our explanation, since 3 squared plus 6 squared does not equal 7 squared, triangle ABC is not a right triangle. So BC is not perpendicular to AB. Alright, which is why we say no. BA can't be the tangent. Alright, that's crucial. Now, in the next few exercises, obviously BC is the radius of the circle, and we're given that AB is tangent to circle C. Alright, that's a given. It is tangent. Find the value of x. Well, if this is a tangent, that means this is a 90-degree angle, so we should be able to do the Pythagorean theorem. In other words, x squared plus 96 squared is equal to 100 squared. Okay, so x squared plus 9,216 equals 10,000. Alright, then we will subtract 9,216 from both sides. That gives us x squared is equal to 784. We take the square root of both sides, and we get, let's see, the square root of 784 is 28. So x is equal to 28. Alright, how about number 5? Once again, Pythagorean theorem. So 45 squared plus 108 squared, 45 squared plus 108 squared is equal to x squared. Wow, that's a big number. 13,689. So that gives us 13,689 is equal to x squared. So if I want to get x, I need to take the square root of both sides. Alright, the square root of 13,689 is 117. Okay, so that means x will equal 117. Okay, and now for number 6, I'm still going to set this up using the Pythagorean theorem, but I am going to do one thing that's a little bit different. So I've got x squared plus 48 squared is equal to 80 squared. Now, here's how I solve the Pythagorean theorem when nobody's looking. I just, rather than squaring these numbers and getting these big numbers, what I do is I leave them in this form and I just move them around. So I'm going to subtract 48 squared from both sides like this. Okay, so that's going to give me x squared is equal to 80 squared minus 48 squared. And then I know if I want to get x by itself, I'm going to have to do the square root of both sides. And what I'll do is I'll just put this entire thing in my calculator. Square root of 80 squared minus 48 squared. Okay, so the square root of 80 squared minus 48 squared. And oh look, I get 64. So that tells me that x is equal to 64. Alright, and for me that's just a little bit quicker. Alright, let's take a look at number 7. Space shuttle. Alright, so you can tell this is an old problem because we don't really have a space shuttle anymore. Anyway, the space shuttle. Suppose the space shuttle is orbiting about 180 miles above the Earth. What is the distance d from the shuttle to the horizon? The radius of the Earth is about 4,000 miles. Round your answer to the nearest tenth. Okay, well, now this 180 miles is just this little part right here. That's 180 miles. Okay, but they told us that the radius of the Earth is 4,000 miles, about. So that's this part. Maybe I should change colors. Alright, so this is the radius of the Earth that I'm drawing here in green. And that is about 4,000. I don't know if you can even read that, but that's 4,000. So the idea is the entire hypotenuse here is 4,180 miles. You know, just adding those two together. Okay. So, oh yeah, and another thing. What about this other side? Okay, so over here, I'm trying to pick a color that will show up. Maybe this will work. So on this side over here, we have the total of these two. So that's 4,180 miles. That's the hypotenuse. What about this side over here, though? Well, guess what? That's going to be 4,000, because that's another radius. Okay? Both radii should be the same. So when I do my Pythagorean theorem, you know, this is the hypotenuse. So my setup should be d squared. Wait, let me switch colors. Here's my setup: d squared, okay, because that's leg squared, plus 4,000. I did two pluses. I see plus 4,000 squared should equal 4,180 squared. And again, something I like to do is leave it in this form so I don't get these crazy big numbers. So I'm just going to subtract 4,000 squared from both sides. Alright, so that's going to give me d squared is equal to 4,180 squared minus 4,000 squared. Alright, so to get d by itself, I will take the square root of both sides. Okay, and that should give me this distance d. So I'm just going to put this whole thing in my calculator, which I find the easiest thing to do. So it's going to be the square root of 4,180 squared minus 4,000 squared. So that gives me this, alright? So it's not a nice whole number, but it's close enough. So 1,213. I'm going to go ahead and round this to the nearest mile. Okay, so that would be the distance to the horizon. Alright, don't forget your units. Alright, look at number 8. This is a situation that we actually learned about before, but you might have forgotten. This is called an inscribed angle. And we learned the relationship between an inscribed angle and the intercepted arc. Talking about this right here, this intercepted arc. Alright, that's a very terrible arc, but you get the idea. For example, we learned that if this was 100 degrees, what would be the measure of the inscribed angle? Well, it would be 50 degrees. We learned that the angle was half as big as the arc, or you could say the arc is double the angle. Okay? When it's inscribed, meaning the vertex is on the circle. Now, consider this. Alright, what if the picture looked like this? And imagine that this arc right here, maybe I'll try to go ahead and draw it. This arc I'm coloring in white. Alright, what if that was 80? What do you think the measure of this angle would be now? Yeah, it would still be 40. Okay, this is still an inscribed angle. Alright, it's still going to be half of the intercepted arc. Alright, well, let me change this picture one more time. Check out this situation. Imagine a scenario where one side of the angle is actually a tangent to the circle. Okay, so that would look like this. So I've got this giant arc right here, but guess what? This is still an inscribed angle. Alright, it still counts as an angle whose vertex is on the circle, and the same formula we've been using still applies. So imagine that this blue arc here is a 200-degree arc. What do you think the measure of this green angle is going to be now? You guessed it, this would be a 100-degree angle. Alright, and I'm saying this is tangent, so I want you to imagine, if I were to extend this line beyond the circle, you would be able to see that this is a tangent line. Okay, and so that still applies. So why am I mentioning that now? Because if you look at this problem, number 8, this is the situation that we're in. Okay, if you look at this angle right here, alright, this angle is an inscribed angle. This counts as an inscribed angle. Okay, and this arc would be the intercepted arc. So if this angle is 101 degrees, guess what the arc is going to be? Right, the arc is going to be 202 degrees. Alright, because the arc is double the angle. Alright, it's just like this situation, 200, 100. This is 202, 101. Alright, but this is not the arc that they asked us to find. Alright, clearly this is a major arc from A to B. Alright, it's bigger than 180 degrees. If they say measure of arc AB, they automatically mean the minor arc. Okay, so they're actually asking us for this green arc here. Okay, now what's the point of having this point C here? I don't know. Ignore the point C. It's not doing anything. So they're asking us for the green arc. But that's easy enough to find. Together the blue and the green make up the entire circle. So I can just subtract from 360. Let's see. So yeah, if I do 360 degrees minus 202, that should give me the green side. Okay, so that's 158 degrees. And that is the measure of arc AB, the green. Alright, keep that in mind. I'm sure that's going to come up, well, frankly, right now. Our target is arc FH. Again, the two-letter designation automatically tells us that we are talking about the minor arc FH. So we are looking for this arc right here. Okay, so we could find this major arc and subtract from 360, or we could subtract 180 from 180 and find this angle and then double it. I think I'll do the first thing I said though. I see the 129. Okay, that's this angle over here. The 129 is this angle. Okay, that's 129. The intercepted arc that goes with that is this blue arc right here. So, if I double the angle, I should have this big old arc. So look, double 130 would be 260. So this must be 158. Okay, I mean I could use a calculator. 129 times 2. 258. Did I say 158? Yeah, that was silly. I meant 258, of course. So that's the blue arc. So how do I find the green arc? Yeah, I subtract from 360. So I will do 360 minus 258 degrees. 102. Okay, so that is the measure of arc FH, 102 degrees. Okay, let's see what's happening with number 10. Alright, the measure of arc JKL. Okay, JKL. That's this whole thing right here. Watch this. Arc JKL starts here and ends here and goes through K. So that's going to be like this. Alright, that's what we have to find the measure of. Now, in the meantime, see these three marks? These angles are all congruent. So I'm going to use that to help me figure it out. Alright, if these are all congruent, and see how it makes this tangent is a straight line? So that means right here would be 180 degrees total. So what's 180 degrees divided by 3? Well, 18 divided by 3 is 6. So 180 divided by 3 is 60. So that means each one of these is 60. So this is 60 and 60 and 60. Okay? Now, focus on the green arc though. Alright, the green arc is the arc that is intercepted by this angle right here. Okay, so remember the relationship between the angle and the arc. Okay, I didn't mean to hit that. Remember this. Remember that the arc is double the angle when it's inscribed like this. Okay, so the arc will be double the angle. Well, look at the angle. This fuchsia angle right here is 60 plus 60. Okay, so that is a total of 120 degrees. Okay, see, how will I write this? I'll use this purple. Okay, so together this is a total of 120 degrees. So if I take that 120 degrees and double it, that should give me the arc. Okay, so that'll be 240 degrees. Alright, and that's how you do number 10. Alright, what else we got? We got to be getting near the end of this thing. We're at the... Oh, there's a whole nother page. Dear Lord. I thought we were almost done. Okay. So, we're supposed to find the measure of angle 1 over there. And, well, let's do this. This major arc out here is 248. So let's just subtract from 360. So if I do 360 minus 248, that gives me 112. Okay, that means this other arc over here is 112. Alright, that's this arc right here. Now remember the relationship between the inscribed angle and the arc. Alright, remember this. The arc is double the angle. So that means the angle should be half as big as this. So if this is 112 degrees, okay, and you should be able to do this in your head, but just in case, 112 divided by 2, that is 56. Okay, so the angle should be 56 degrees. Okay, how about number 12? Alright, I'm going to go ahead and stop this video here. Number 12 is starting with a different type of problem, and we have several more problems like that coming up, so they should be all included on the next video. Alright, so we'll do this type of problem on part 2. See you then.